So I would like to ask for any question you have, because I would like to just hear your question, maybe the first couple minutes, and I'm going to prepare to explain a few general concepts about homework assignment number one, as some of you already asked related question earlier in the lecture today. Okay, so beyond what have been asked, what are the other questions you have that I should address publicly?
Yeah, so for since there are two servers, the first one is Hw1 server, the other one is Hw1 another. So inside those two servers, they kind of handle different objects, either person or flights. So so for the person, I'm kind of because in both in Hw1 server and Hw1 another, both of them have the same person, which corresponds to the name being Lion King and Lion Queen. And but for the flight, it actually has different IDs, which so in Hw1 server it has 1, 2, and 3, but for Hw1 another, it only has 3. So I'm kind of wondering, like, which objects we need to placed at which server. Like, is it decided on our own, or we need to follow some instructions?
To make a short answer, yes, you make out your own. You decide whatever you want to place it. Yeah.
Okay.
I do not have any restriction about how you want to place it. Yeah.
Because in Hw1 client.cpp, it kind of allocates different things, or I mean, just create several shadow objects. But some of them are, since some of them do not exist in some of the servers, which means when they call some method, it may fail, or if that object exists in that server, then the status would be successful. So that's why probably I think I would just stick to what is written in Hw1 client.cpp and to get it work, and then trying to either add some other things, right? May I know if that's
sure.
correct?
That's actually reasonable, but I do want to emphasize the idea of a reference implementation is that this is just give you as a reference, so you have a lot of freedom and flexibility to make change yourself. You can remove the object, or you can add a few objects in different places. Let me actually just clarify a few things. Is that the purpose of this homework assignment is really just get you familiar with how to do some programming in a distributed system. So we're just in fact, I just want for you to make sure you understand two things out of your homework assignment number one. Number one, you know how to do RPC, remote procedure call, which is a very general, useful package for you to be able to run remote procedure call over this kind of web protocol. And the second thing I really want you to do is just make sure you're familiar with JSON programming, because in the current paradigm for doing distributed computing is the information being exchanged is essentially JSON. If you have this non-SQL kind of situation, which is essentially non-SQL is essentially related to the same as JSON. And therefore, I want to make sure that you know this part, which I think is great for any CS student to learn about this. And then when you actually build a project or whatever program later in this quarter, this is pretty generic, pretty extensible, and it is going to be language neutral in that sense. Okay, that's just tell you that that's the purpose for me to assign you to do this homework. Okay, all right. Let me actually just try to start it by answering some of the question that was asked about an hour ago. I'm going to share my screen. Okay, I assume you can see my screen, right? This is being recorded, so I just want to tell you what is going on. So I want to start it with this one. So I think you understand. I assume you already know that the concept of remote procedure call. I'm not going to go over that. If you have any question about that, I can address that. But I assume you understand. This is the concept of JSON RPC. You're using JSON to actually specify. And the program JSON RPC stub is the part one of homework one. I want you to be able to install that. Once you've done that, you will be able to generate the code. Looks like that. But the core concept of this homework assignment.
Professor, could you please quickly go over what RPC is? I'm not really familiar.
Okay, I will go really quick into this.
Thank you.
So what is RPC is that usually when you write a program, you make a function call. That program, it must be already within the same, either in the same program or in the library. So you make a phone call, but not phone call, make a function call. For example, you call to do a cosine, compute a cosine, you compute a matrix multiplication. So that is basically what we call a procedure call. So remote procedure call, essentially, we separate your program into two parts. So you have so any function call, you have what we call a caller on the left and the callee on the right. Sorry, this is a caller. In this particle, I actually make a function called foo. And then the other particle is actually the implementation of foo that when you call that function. So usually traditional function call, these two must be together. So the process we call linking. We're linking the program or library or different object file together. So it forms a large executable file. And that file is going to be one single process. So traditional procedure call is both the left side and the right side, both the caller and the callee. They're both in the same process. They're in the same memory map. Okay, so that's traditional call. So remote procedure call, essentially we break this call into two parts. So essentially we break them into two different processes, two different memory maps. And the mechanism is that it looks like on the right-hand side is still make a call, but the function really handling that call is actually on a server on the other side. That's why this is called remote procedure call. We actually split it. And the way we define, I mean, remote procedure call was first developed, the concept was first developed around 1990, maybe a little bit earlier than that. It's a Sun microsystem at that moment. And so the idea is that, okay, in order to make this remote procedure call work, you have to use a language to specify the interface. Because the client is going to talk to server, you must have some kind of interface for you to make sure you understand that this is the call. I'm actually transfer or coordinating between two different programs. One is called the client part, one is called the server part. So essentially you specify the interface using a JSON format, which I'm going to show you an example. It's already included in the reference implementation. So that JSON interface is going to be the input to this program. That's actually for this JSON RPC package. You must have this program called JSON RPC stub. That's why I want you to install that to test you have an implementation there. So that program will take that JSON interface specification and create two programs. One program is called client.h, one program is called server.h. And the client.h is going to be used by the client side to connect the program, and the server.h is generated code. I will show you what it looks like. It's actually going to be used for that. Okay, so that is a remote procedure call. Does that help you understand a little bit?
Yes, so much. Thank you.
You're welcome. We'll go into the code, then you will probably see a little bit more. Okay, So that's called remote procedure call. But the thing is that I really want to do is implement a concept called shadow object. You can think about shadow object as a proxy. And I think one of the students make a comment, which I really like, is actually a chained proxy. So it means that you might have a multiple proxy in the middle before you can hit the end. So what is a shadow object? So shadow object is saying that, okay, I'm actually on one particular location of the internet, and I like to interact with some object. You can think about object as just some kind of data associated with the program that's going to manipulate the data. So the thing is that I'm actually on one particular location in the internet, maybe with my smartphone. I'm actually going to interact. I want to use this object. But the thing is that there are two cases. Whether this object is right next to me, is actually on my machine already, or this object is somewhere else in the internet, that's actually for me to retrieve that. I mean, just give you an example. I try to access my bank information for myself. So my bank information might be just on my smartphone. I can actually access to that. But the thing is that it could be that my bank is actually distribute that information into one of the server they have around the internet, which I'm not supposed to know. And with the mechanism of shadow object, I don't even need to know, because a shadow object is represent a proxy for you to, looks like to your program, you're actually talking to a local object. But that local object is not a real object. It's actually a proxy, or it's a shadow for you to actually connect to the real object somewhere else. And I just give you an example. This could be when you actually access your Facebook information, the shadow object might redirect your request to one of the 5 data centers around the world, depending on how your network locality is binded to. That's one example. You can see that you're accessing an object. That object looks as local, but it's actually remote in somewhere. The other example about your bank, as we mentioned, is that I try to access my bank information. Of course, my bank information does not tell me where that is because it's a security. So it always refers me to one of the branch in Davis downtown. So when I open up my Chase application, Chase application will redirect my information to a particular proxy, a server actually in the Davis Chase branch. But that is still not my real information, because the real information Chase actually protected. Maybe they put it in New York or in Los Angeles. I don't know. Maybe Seattle. I don't know. But that server at UC in Davis downtown, they have the information to redirect the request to a real bank account object for myself in, say, in Seattle. So the thing is that my shadow only know, the first level of shadow only know that, well, that object, I should actually go to Davis. But Davis also has a shadow to actually connect to the other server in Seattle, Chase branch server over there. So in that case, you can see that my phone is Hw1 client. The one in Davis downtown Chase branch is actually Hw3 server, and the one in Seattle is Hw3 another. So that's the kind of concept. You can see that there are multiple objects they're linking together. Every time they link together, they're actually making a function call. They're using remote procedure call to do that, which I'm going to show you just a second. So I just want to tell you that this is a scenario we try to implement. Okay, so before I actually show you the code to dig into that, I want to show you what have been given to you as the file, because some of you are actually kind of a bit confused about, why I'm getting this file, what is this file doing? So I have actually a slide to actually talk about this file. So this file, by the way, is actually in the turn of Hw3. So if you look at Hw3, for you, it's Hw3, it's Hw1, okay? So let me actually look at, this is essentially roughly the file you actually receive, okay? But it doesn't have an HW3 another, okay? The first generation, when I release, I only have client server. I don't have another, but another is just another server, okay? So here's a file looks like. The first one is .json file. The .json file, the blue line, is actually generated by JSON RPC stub. It actually create this file called hw3 server.h, hw3 client.h. And then I basically I already have a simple program for hw3 server.cpp, hw3 client.cpp. And this two program is going to link this 2.h file such that when they generate executable file, they will be able to talk to each other according to what is the remote procedure call specification being specified under this JSON file. Okay, let's actually stop here without going through the rest of the slide. Let's actually look at the code, looks like how the code looks like, okay? What is going on? Let me see. Okay. Move these things up here. Okay, I hope you can see my window. Okay, if you unpack the reference implementation, I sent it to you, and this is all the file is over there, okay? And I'm actually going to show you this one. First, I said RPC specification. This is RPC. I actually have a two file. One is ecs251 Hw1 JSON. One is ecs251 Hw1 all 4 JSON. The difference is that this is used for reference implementation, only have a one of the 4 function call, which is get distance. And the Hw1 all 4 has all 4 functions specified, which is get distance, get VSID, operator equal, and conflict of interest, those 4. I'm going to explain to you later. But let's take a look at the first one, the easy one. See, this one only specify one function. You can see that this is the one, this is essentially, if you start to learn about JSON, this is called a JSON array. JSON array is, in JSON, if you specify as a bracket, it's an array. In this case, the array has only one element, because I only have one call. And this element is an object. The term in JSON is called object. And each of the object has a one or more what we call key value pair. So the first key is name. The name of the function is called get distance, capital G, capital D. And it actually take 6 parameters for the two functions, the function, the caller and callee to communicate. And then there was a return value about what. So I just want to tell you for C++ RPC, return is actually, you can neglect it. Return, you will see that in my code, is only really one JSON pair is relevant. The rest is not relevant. Okay, so this is one object with a 3 key value pair. And the first key is name, the second key is parameter, the third keys are return. So this is a JSON array to specify the JSON RPC spec, but with only one element. Let me actually compare this 4. Compare all 4. Look at this. This is still an array. The first function is get distance. I have it here. And then using a comma to get the second function, which is conflict of interest. And conflict of interest is almost the same. Still 6 parameter, the name is different. And then the third function is called operator equal. So operator equal, you notice that the number of argument is actually more than that, because the reason is for get distance, give VSID, they don't have argument. They don't have any argument. But operator equal, this is operator overloading in object-oriented language, that you need to have a another parameter for you to compare against this operand, which is the equal sign. That's why you have another pair of parameter. That's why it's there. That's the third function, and the fourth function is give ESID. Also don't have any argument, so that's the 4, and then you have array. Okay, so that's basically the specification. Okay, now I'm actually going to do one thing. I don't want to make all. If I make all, I'm actually generate everything. But I want to tell you that at this time, you didn't see any .h. You didn't see any Hw1 client.h, Hw1 server.h. Remember I said this program is going to generate this 2 file, right? So let's actually take a look at the make file. You can see that in the make file, I actually have a rule. Hw1 client.h, which is using JSON RPC stub, and the input is this file I just showed you. And basically it talk about the server's name and the client name. So you have to look at the, let me actually make this a little bit longer. Yeah, now is good. So using this line of code, you will be able to generate Hw1 client.h, Hw1 server.h. So let's try to run it. So I assume you're familiar with make. If you're not familiar with make, that's another thing you need to pick up. All right. So I will just type in make Hw1 client. I'm triggering the first rule, Hw1.h, because that is the target. So I actually trigger that rule, say make Hw1 client.h. You see, it actually asks you this lines of code. And after I ask you that lines of code, you see that I'm actually now has generate Hw1 client.h, Hw1 server.h. Those 2 files got generated. So let's actually take a look at that. Let's first take a look at Hw1 client.h. If you look at the file, you will see that, oh, this file is generated by JSON RPC stub. Do not change it manually. Okay, that's number one, you know. But then it basically say, okay, I'm actually going to create a class called Hw1 client. And it's actually public to inherit from JSON RPC client. You don't have to worry about inheritance at all. And it has a one constructor. You don't need to worry about one constructor at all. In fact, you don't need to change. This is just for you to help you to understand. But this is part of the code is actually interesting. This piece of code, starting from here, from here, over, let me actually see if I can put everything in one page. Yes. From here, all the way to here. That's actually the code generate to implement the remote procedure call called get distance. So this side is how you're going to make a call by putting into this 6 parameter that we specify in that JSON specification file. And inside the code, look at what they did. They actually generate this, by the way, this part of the code, this part is called JSON programming. You just basically specify, I want to create a JSON object called P. JSON column value represent, it's an object. So there is, you create a P, which is a JSON object, and then you start to insert each of the key value pair. Remember, everything in JSON is key value pair. So that's why you have this, the first key is action. Okay, by the way, this is corresponding to blah, 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 251, homework 1. No, where's that? Homework 1.json, sorry. This is actually correspond to this 6. 1, 2, 3, 4, 5, 6. So the first key is action, owner, VSID, whatever. Okay, this is 6. Okay. So that's why action, argument, class ID, all this. And where do I get the value? This is the key part. The value part, you actually need to pass in from the function. So the caller is going to provide the value, and inside this code get generated, it will actually encoded whatever value you provide into the JSON object format. And then after you've done this, then P essentially is a JSON representation about the function call plus the parameter you're going to send it to the remote RPC. And then this is part is going to be called. It's really nice is you just say this call method and the function name, remember, get distance. Where's the get distance? That was again, this is the function name, get distance. So when I say get distance, it match with this function call, both client side and server side. And then the second part, the function name, and then what? Parameter P. Okay, that's it. That's you provide the function name, you provide the argument, you send it over there, and the return from the call, which is now the rest is handled by JSON RPC library. You don't even need to worry about that. And then the result is actually going to be whatever is getting there. And it's also a JSON. Remember, whenever you see JSON column value, it's a JSON object. And then you basically doing some processing to actually return the result to the caller of that remote procedure call. That's it. That's for Hw1 client. Okay, so let me actually just since we're here, so I want to tell you how this piece of code, Hw1 client.h, is connected to Hw1 client.cpp. Remember this function is called get distance, right? All right, let's actually look for Hw1 client.cpp. Okay, this is the program. I want to just show you one part of code. This part of the code, I'm going to, not this part of the code. Oh, I know. Okay, so this part of the code is going to call a function called get distance. And this get distance is actually going to be on the shadow fly because get distance is a virtual function. And this object SF3 is a shadow fly. So therefore, the get distance function is going to define in shadowfly.cpp. So let's actually go to shadowfly.cpp. So inside shadowfly.cpp, now we actually be able to see this part of the code. This piece of code is get distance is from the Hw1 client.cpp. It's going to call get distance. Okay, so let me actually tell you what the first three line is. The first three line is essentially set up the web or HTTP address about where is the locality of the server I'm going to call. So I'm going to tell you later about how do I decide using this host URL a little bit later, but this is the typical piece of code in this two line. So essentially you create a HTTP client, provide the host URL, which we will talk about that. And then you actually create Hw1 client, which is this code is part of Hw1 client.h. And then you send my client, HTTP client, which is this one, you just define and just specify I'm doing it with JSON RPC, whatever client version 2. Okay, once you have this two line, you can actually now go to make a real call. You see that now I'm actually going to say my client dot get distance because Hw1 client is the class that we just specified in Hw1 client.h. And now you can see what I did here is there are 6 parameters. I just basically, the first parameter is get distance, and then has a second parameter. This is the action. This is, I think, I forgot what's the second one. And then I have a 4 object. One is called class ID, object ID, host URL, and owner VSID, which is, again, correspond to this 6 parameter: action, owner VSID, host URL, class ID, object ID, and argument. And argument, essentially, I'm not using it. I'm just put a random string there, okay? Okay, so this is the call. When you call my client.getDistance, it's actually going to call the code defined generated in Hw1 client.h, and then the return value is my V. My V is a JSON value. So now I'm going to extract the result. And the way I set it up, I will show you the server code so you can correspond to this part. But essentially, I'm taking this and using the key value pair extraction. I said the key is distant. So essentially, that means the server side, I insert the result as a double number and then put that into the JSON encoding with the key distance. And then when I take it out, I actually have to convert that encoding into as double. So that's why I'm actually returning as a double number to return to the shadow fly get distance. Okay, so that is the shadow fly. Let me actually just compare the difference between shadow fly and fly.
Before
So you got
going,
some idea. Just give me 30 seconds. I will get back to you. So if you go to fly is actually under transaction. Okay, over here you see that there is a get this. This is a fly. This is a shadow fly. No, sorry, just 1 second. So this is the real one. If this fly object is really on the same machine, then essentially you're calling the flight departure, compute the distance, whatever you call this function. That's just return this as a double value. But if it's a shadow object, then essentially the get distance is going to be extracted from the remote. Where do I got my V distance as double? I get it from my V. Where do I get my V? I actually get it from my client dot get distance. Where do I get that? It's from the server side. Okay, I'm going to stop. Question.
Can you go back to the program that we were looking before, where you had these two lines that you did first? Oh yeah, there.
Yes.
Yeah, what was these two lines again?
Okay, this line, the first line is setting up because remote procedure call, remember there is a remote server I need to connect with, right?
Yeah.
So what is the remote server? So we think about this server as a web server. So essentially, it's a nice thing about the remote procedure call. It's really calling a remote web server. So how do I actually connect to a remote server? Is URL, right? It's a universal resource record. So what it does is that this HTTP client, when you set up, all you need to provide is the URL. So this part is a URL, is this host URL.csctr. Let's actually take a look. So this, by the way, there was one thing I want to tell you is that if you see CSTR, this is just a translate between C++ string to C string. That one sometimes is unnecessary. I probably just a little bit more careful, so I just pessimistic, I put it there, but it might not be necessary. But I want to just focus on how do I actually set it in this host URL. Take a look at this. This is Hw1 client.cpp. I skipped this part. So in Hw1, let's take a look at this. This two line. When I create SF1, when I create SF3, SF3 has 4 parameters. The first parameter is a URL. That is this host URL at the time when the object was created. So this URL, I specify as a localhost colon 8384 is a port number. So basically, I'm not using the standard 80 or 8080. By the way, in web programming, you can set any port you want. I mean, I typically like to set different than this 8080 because those ports are being used for other purpose, for real web. But for me to do the web programming just with a different port number, you can actually pick any port number you want. So in this case, because I know you'll be running on the same machine, That's why I set anything to be localhost. But in a distributed system, this part could be replaced by any URL or any IP address. You can do it here. Okay. So just let you know that this, when you create this object SF3, the first argument is actually this argument here. This, because this is SF3. And SF3's host URL is being taken by this. So the whole thing, let me just tell you that this part is the same. Just tell you that these two are exactly the same in terms of their functionality. This code and this code are basically, in this case, is the same. In this particular case, this code is essentially doing like this. Okay.
Okay.
Is that okay?
So in this one line, we got this.
You essentially set up the IP address of the other side for the HTTP client. Because okay, let me give you another link. Here you create an object called HTTP client, right?
Mm-hmm.
And then you actually, when you configure the RPC client, the first parameter is that HTTP client. So this line and this line, you actually connect your my client to a particular location associated with that URL.
Okay.
Yeah. Okay. Remember this one, 8384? Remember this 8384, right? Now let's actually take a look at the other program.
Mm-hmm.
Okay.
Professor, I have a quick question.
Give me 1 second, okay? I just want to show you where is 8384. Okay, so inside, this is the server, HW3 server, Hw1 server.cpp. I create a bunch of real object, whatever, but here I'm actually set up the server. You see that? I set up the server, the port number is 8384. So I only, when you set up a server, you only say, what is a port number I open up to? And then I create my Hw1 server using HTTP server I just create. So with this two line, I actually configure my server to match up with the Hw1 client, those two lines I just showed you. And then I start to say, start listening. I just start listening about any requests coming in. It will actually invoke the program. Okay, yes, what was the question? Sorry, I interrupt you.
Okay, I just want to ask that if we can change homework 1 off for .json, because I want to ask, because we have to implement operator equal equal, right? And in operator equal equal, I found that you judge if SP1 equals to the SP3, but SP1 is on the server, and SP3 is on another. So how do we judge if they are equal? I mean, I think I should add another function called my name, so I can judge they are the same.
Okay. So first, I want to specify that the definition about operator equal equal, it should be just compare if your VSID are the same. The name doesn't have to be the same, but the VSID has to be the same.
I see. Thank you very much.
Yeah, the semantics, let me actually take a look at the operator equal equal. Operator equal equal is actually the original one was defined in person.cpp. Okay. So
Yes,
this is operator equal equal.
Name.
Oh, you know what? I shouldn't do that. Yeah, that
so
need to be changed.
Sorry,
my mistake. Should be. I'm glad you asked the question. I thought I already cleared this. It should be just like this.
Okay.
It should be just like this.
Yeah, that's fine.
Okay.
Thank
so
you very much.
let me tell you that this is interesting. This is interesting. If you look at this piece of code, when you get to this piece of code, that means this means that the right-hand side of the operator equal must be a real object. So first we need to deliver this operator equal to the real object of the first operand, which means the right, when we say operator equal in the code, it's usually say is whether A is equal to B, right? The way we write code, it looks like this. So A is a first operand and B is the second operand. Just let you know, a very quick refresh of C++. So this is actually technically equal to A dot operator equal B. I don't really know that this is actually the way C++ really implement. If it's, you say A equal B in operator overloading, it's actually A dot operator equal B. So B is the parameter. But when you actually get this thing's call, B is a person. Okay, so now here is a situation is that the A person itself could be a real object or could be a shadow object. So if it's, however, I do want to clarify is that in your scenario, you can actually make all the person object in the same host. That's okay to make your development a little bit simpler. But if you develop a full-blown, very flexible implementation, then it doesn't matter whether this A person is a shadow or the real. Because when you actually call, if A person is a local object, the get VSID will get the local VSID. But if the A person is a shadow, then basically you're going to call shadow persons get VSID together from another server. So just let you know that. Okay. Let me see, there's a chat. What do you mean by this, creating a free function for that right? Ms. Threya, I think you asked a question in the chat.
Yeah, sorry, my bad. I was thinking about something else.
Okay, sure. If you remember something, just let me do. Yeah, I will, Shimona, I will assign the breakout room after I think I'm almost done, okay, with the program, okay? Okay, so let me just let me try to get rid of this so I can go to the breakout room mode. Oh, no, better clear this. Okay, the only piece I haven't talked about is Hw1 Server.H and Hw1 Server.cpp. So let's take a look at Hw1 Server.H. This code is essentially defined just like very similar to Hw1 Client.H. It actually define another class on the server side, and then it has constructor. And you can actually neglect this inline virtual piece of code, but directly look at this piece of code. This piece of code is defined get distance. This get distance is exactly the same as the function that we have. Okay, now I'm going to testing for some of you who might not familiar with C++. I want to ask you, what does that mean when I define a function? When I define a virtual function, and at the end of function, I set equal to 0. What does this mean? Anybody familiar with this? This is the C++ syntax.
It means it's a pure virtual function.
Exactly. That's a pure virtual function. Pure virtual function means that this is a pure virtual. It's not supposed to be implemented. So essentially, looks like in Java, this is a virtual class, essentially. Okay, so the real class is going to be defined in the Hw1 Server.cpp, which I'm going to show you. So inside, now we'll go back to Hw1 Server.cpp, and then we actually define that one is Hw1 Server. Now I'm actually just define the real thing. That's why now I have this get distance defined over here. This is the function signature is exactly the same as that pure virtual function in Hw1 Server.H. Why they did it this way, to be honest with you, it's a long answer. So I'm not going to bother to explain why they do that. But anyway, here you see that I have a constructor, that's fine. But now I have a get distance. This is a function which is matching with that function signature. So when you make a remote procedure call, when you say call method, that the server call will actually invoke this call, fill in those parameter you just provide with that JSON encoding. And so inside here, I start to process this information. And then this particle is actually very standard. You don't have to understand or even do anything. This particle is just prepare for the value to be returned. What value to be returned? You see that I'm actually have a distance. Remember I said there is a return has a key value pair. It's a distance. Where's the distance? Control 2. This distance must be in shadowfly.cpp. Inside shadowfly.cpp over here, you see that there is a result. I extract the result of the key value pair is distance. That distance was actually being encoded over here in Hw1 server. That's the distance I encoded here. So I encoded strJSON as the result, and I actually using the next 5 lines of code, just encoded into a JSON format, encoded into something called result. Okay, that using this function. If you don't have time, you don't need to understand this 5 or 6 line. It's just basically convert your string into a JSON object. And then I just return the result. Bingo, things will work magically. Okay, so I just want to show you very quickly about how to run the program. So now I'm going to make I think I missed because I make a change. I forgot one parenthesis. This should be get distance. Sorry, this should be operator equal. Okay, here I miss one parenthesis. Okay, you see I have all the program compiled. Now I have a 3 program, Hw1 client, Hw3 server, and Hw1 another. So I'm going to create 3 window, 3 terminal window. Okay, the 3rd window, I just run Hw1 another. And then the 2nd window, I say Hw1 server. They're just listening, but they haven't done anything. Now I'm actually running Hw1 client. See, I'm actually sending out stuff. Get distance is actually getting the 2nd part, and then also connect to the 3rd part because there is a real object is actually on another. Okay, and just to let you know, Hw1 another, the port is not 8384, it's 8385. I'm using like 2 different port number to identify which server I'm in. Okay. All right, I actually went through this very quickly about how this is going to be done. Any question?
Yes, Professor, I have a very quick question. I noticed that in your homework1 client.cpp, you commented out like a bunch of things concerning shadow person and person. I'm wondering, like, since you didn't provide the shadow person in the, the tar file, should we like define the shadow person ourselves and uncomment all these things?
Yes, you need to create shadow person.cpp in order to, and shadow person.h in order to implement the other 3 functions. But you don't have to uncomment everything. You can select, I mean, my advice is for you to uncomment the least amount of code to make sure that all 4 functions will get called. That's enough. So by the way, I forgot whether I mentioned that in the homework assignment. There are 2 issues I'm looking for you to get full credit. Number 1, you actually have the server and another. Means that you have a program which both acting as a client and a server, which the reference code already done that. So that part you don't need to worry about. But the second part I'm asking you is that you will implement all 4 functions. For the other 3 functions, you actually need to do shadow person.cpp and shadow person.h. Let me just give you a very quick look. I'm not going to show you the source code, but you can see what is the end result looks like, okay?
You see this.
I have too many programs actually. I want to see which one. I want to use this one. Okay, this program actually has more than you need, but I just use this as an example. So if you take a look at this program, everything else is exactly the same, except I have shadow person.cpp and shadow person.h. And that's the only thing that's actually required. And the other thing you should be notice that I changed the make file because now I have to compile those files. Okay, I do have a note. I now remember this is what I actually mentioned. This is probably when I explain how to implement operator equal. I actually go through the different places that's actually related to that code. I actually have this file. If you want to use this, I can probably send this to you as well. I probably will send it anyway. But it was kind of like I just copy code here and there and make it a bigger file. Okay. Angela, is that answering your question?
Yes, it's very clear. Thanks. Just one last question
Sure.
regarding that. So since we have to do all 4 calls, I guess we're going to have to change the JSON to all 4 in the make file too, right?
Yes, that's correct.
Okay,
That's
got
correct.
it.
Yeah.
Thanks.
Yeah. Okay, any other question? Okay, I'm sorry, I'm running late, but I still want to do breakout room. So I'm going to send each of you to individual breakout room. And if you don't have any individual question you want to ask me, you can just leave the Zoom program. So I will see whoever stay there. I will do round robin and then go to each of the room. Okay. Let me first turn off the recording.